All right, let's build a machine learning model that actually works in the real world. I'll show you the blueprint.
Ever had a model that looks perfect but then just bombs in production? Yeah, let's fix that.
So we're going to build a model that doesn't fail. Our guide, the classic wine quality dataset.
The challenge is pretty straightforward. Predict a wine's quality based on its chemical makeup.
Okay, part one. Here's the secret. Great models start with great ingredients, not a fancy algorithm. So instead of just using alcohol by itself, let's create a new, smarter feature by combining it with density.
And check this out. Just that one new feature boosted our performance by a massive 9%.
All right, part two. Now we're going to tackle the #1 killer of models in production, data leakage.
Leakage basically gives your model the answers to the test. You get amazing scores that are totally fake.
Here's the wrong way to do it. Scaling all your data before you split it. Big mistake.
And here's the right way. You split the data first and then use a pipeline to handle the rest.
So what's a pipeline? It's a pro tool that chains all your steps together, which prevents any leaks.
For our wine model, the pipeline is simple. First, it scales the data. Then, it trains the model. Safe.
Okay, part three. Our process is leak-proof. Now let's crank up the performance.
We use something called k-fold cross-validation. It's how you get a performance score you can actually trust.
Next up is tuning. Think of it like dialing in the perfect settings to find that performance sweet spot.
Part 4. The moment of truth. Let's see how much our blueprint actually improved things.
And there it is. The tuned model is way more accurate than our baseline. The whole process just works.
And get this, the most important feature? It's that new one we engineered right at the start.
So, part 5. This entire workflow isn't just for wine. It's a universal recipe for any ML project.
So let's recap the blueprint. Start with features, use pipelines, cross-validate, and then tune. That's it.
Now you have the blueprint for models that don't just work in a lab, they work for real. So, what will you build?